Today, we're going to continue learning about triangle inequalities. We will be able to determine whether a triangle can be formed given 3 segment lengths and determine the range for a possible third side length given 2 side lengths. So thinking back to our last lesson, write the possible lengths for the third side of the triangle given the lengths shown. So we know that x could be the longest side, or it could not be the longest side. If it's not the longest side, we know that it has to be bigger than 13 minus 9. If it is the longest side, we know it has to be smaller than 13 plus 9. So if we simplify, we know that x has to be in between 4 and 22. Let's look at some more extensive side lengths. What if our side lengths are 6, 10, and 2x plus 4? If 2x plus 4 is the longest side, then we know that 6 plus 10 has to be greater than 2x plus 4. If 2x plus 4 is not the longest side, then we know 10 minus 6 has to be less than 2x plus 4. So we're going to set this up with our x's in between. 10 minus 6 is going to be the smallest number, is less than 2x plus 4, which we know is less than 6 plus 10. If we simplify, we know that 4 is less than 2x plus 4, which is less than 16. So now we solve. Since we have a compound inequality, we want to get x by itself. When we subtract the 4 here, we need to remember to subtract it on both sides of the inequality. And again, when we go to divide by 2, we need to divide it to all 3 parts of our inequality. So 0 has to be less than x, which will be less than 6. So our side length has to be in between 0 and 6. Let's try another similar example. We have 2 side lengths of 6 and a side length of 2x minus 2. We know that 2x minus 2 would either have to be less than 6 plus 6 if it's the longest side, or bigger than 6 minus 6 if it's not the longest side. Take a minute and try to solve this on your own. Pause the video while you're solving and then check your answer with mine. Hopefully you got that x has to be in between 1 and 7. On to our final example. You're standing 200 feet from a tall building. The angle of elevation from your feet to the top of the building is 51 degrees. What can you say about the height of the building? Well, before we can determine anything about the height of the building, what would be the third angle of this triangle? If this one is 90, we know there's only 90 left for the other two. 90 minus 51 would leave 31 degrees for this side. In the last lesson, we talked about how the smallest angle was across from the smallest side. So we know this side with the 200 feet is the smallest. Therefore, we know the height of the building must be greater than 200 feet because this is not the smallest side. We don't know if we know it's not the biggest side either because 90 degrees is on this side across from this side, but we do know that it has to be more than the 200 feet down here. Finally, for your summary, what are other examples of situations outside the classroom where knowing how to compare sides or angles could be useful? Write your summary, and we'll see you in class.